네, 알겠습니다. 나중에 따로 해야겠네요. 네. All right, so we can get started. So welcome to week 2 of AI612, Machine Learning for Healthcare. Well, just a recap. So last time, so anyone who hasn't been participating for the first week, you can check the previous videos on YouTube. But before, if you want to do that, you need to actually enroll yourself on Classroom. So again, just as a last notification, please use this invitation code to get yourself registered on Classroom. All the previous videos and previous slides are all uploaded there. So if you haven't caught up on the previous material, please do. And last week we talked about how to get access, how to request for access to Mimic3, the open source electronic health records dataset, the EHR dataset. And then we looked at the basic structure of Mimic3 and some of the admission patterns and how many tables there are, the schema, because it's a database, it's a schema, there's schema, and then see how to use the SQL query to take a look at the contents of Mimic3. And then additionally, we briefly took a look at the Mimic 4, the new version, and the Philips EICU, and the Korean National Insurance Claims data, 한국 심평원 청구 data. Yeah. So that was that, and I hope that everybody is at least kind of familiar with Mimic 3. And I noticed that already one or two students already have requested for access to Mimic 3. So I granted, well, I mean, so one of the MIT people, they reached out to me. So I gave them I told them that I'm starting a new course. So about 80 people will be asking for access. So hopefully the student who already asked for the access, hopefully got the access now, and then we can download the Mimic 3 open source Mimic 3 CSV files. By the way, any question regarding the access request to Mimic 3? Any difficulties or anything weird? No. Any hiccups? Nothing?
교수님, 혹시 소리 들리세요?
네,
그
들립니다.
휴먼 리소스인가?
네네.
휴먼 서브젝트 그걸로 들어갔는데 거기서
네.
나온 데이터 or 스페이스먼 콜수가 없어서
네네.
바이오메디컬 그걸로 먼저 눌러서 콜스를 듣긴 들었는데요.
네.
근데 그 데이터 스페이스먼이 어디서 찾아야 되는지 모르겠더라고요.
근데 제가 그걸 받았을 때랑 조금 다를 수 있는데 혹시 그 대답해 주시는 학생분 계신가요? 누가 채팅에도 올리시네.
감사합니다.
네, 해결되셨나요?
네, MIT
네네.
어플리에이트로 하면 되는 것 같아요.
예, 그거 자기 학교가 아니라 MIT 어플리에이트로 하셔야 돼요. 네네.
네, 감사합니다.
네. Yeah, it could be confusing, but when you first go through the city training, you have to select MIT affiliate instead of KAIST. So, yeah, I remember being confused about that as well. Right. So yeah, so please go through the city training, get the completion report PDF file that enumerates which courses you have taken, and that you can upload on PhysioNet. All right. 질문 없으시면은 넘어갈게요. All right. So actually I forgot to mention some of the ongoing. Okay, something on the chat box. Yeah, right. So hey, nice to see you again. All right. Anyway, so last time when I was introducing some of the well-known EHR datasets, I actually forgot to mention the new project that is ongoing by which was held by the Korean government, especially 보건복지부, which is the Ministry of Health and Welfare, I think. Health and Welfare, 보건복지부. I'm not sure what it's called in English. Anyway, so 보건복지부 has started a project constructing the Korean version of Mimic, which has not been done yet. So it's just begun. So it's not there yet. So it's an honorable mention. So anyone care to guess the name of this project? 뭘까요, 이름이? 네, 사실 제가 슬라이드를 이미 올려놨기 때문에 아시는 분들은 아시겠죠. 네, 한국형 미믹이니까 당연히 이름은 네, K-미믹입니다. K-미믹. So yeah, so a new project named K-mic is ongoing. So the motivation is very admirable. So let's construct an open EHR dataset like Mimic 4. So actually, so the people at 보건복지부, they have already looked at Mimic 3 and Mimic 4, and they know that Mimic 4 is coming out. So something, the motivation is that, or the goal is that let's construct a some ICU datasets, incorporate ICU datasets, including both children or neonates, 신생아, and adults, just like Mimic 4 actually. So, and the of course the underlying motivation is that we need open datasets to encourage new industry and innovation. So, 우리도 어쨌든 이 오픈 데이터셋이 있어야지 뭘 할 수 있기 때문에, 안 그러면은 전부 다 모두가 미믹 3나 미믹 4를 쓰면은 사실 이제 남의 나라의 데이터셋을 뭐 남의 나라 일 도와주고 있는 거나 마찬가지죠. 이제 우리나라도 병원 많으니까. So we have, I mean, the healthcare system in Korea is very advanced actually. If you compare the healthcare system in Korea with any other systems in the Western countries, I don't think there are a lot out there that is better or at least as good as ours. I guess that maybe Finland. Finland has a very, very advanced EHR system. Their entire 5 million population EHR records are all stored in the central database. So anyone can access, I mean, not like anyone can access their own EHR data and then view or edit, so which is very advanced. So hopefully we can, someday we'll be able to do that. But anyway, before, so we want to, or the 보건복지부 wants to construct a mimic-like dataset, and unfortunately, they want to construct exactly like mimic. So all the table schemas, the table names, the types of tables is exactly the same. So I hope that there are some flexibility. So let's hope for the best. But so ideally, I would like to see a K-mimic, which is downloadable like Mimic 4. So anyone, including yourselves, anyone who is interested in Mimic 3 or Mimic 4, they can go through the city training, the ethics education, and then if they have a advisor and they have a legitimate reason for accessing Mimic, like research purposes or whatever, then anyone can download the original CSV files. So hopefully, or ideally, K-mimic should be like that, like downloadable, as long as you have a legitimate purpose. But in reality, in Korea, I've said this before, but in Korea, there's no consensus on how to handle privacy. So it's just a very vague, like hospitals or anyone who handles private data, like banks or hospitals or whatever, like or financial privacy, your health privacy. Anyone who handles private data, they need to do their best not to leak their data or not to have anything compromised regarding privacy. So they need to do their best to protect their privacy, which is a very vague term, like what is doing their best to protect privacy. So that's why no hospital in Korea wants to release or open source their data set, because they don't know what the repercussion might be. So even if we build K-mimic, it probably won't be downloadable like Mimic anytime soon, unless there's a strict, like a clear, explicit law like HIPAA, which I'm sure that most of you are already familiar now because you went through city training. So HIPAA, as I said, lays the guideline as to which information must be hidden or must be protected, like which kind of measures must be taken in order to qualify as a de-identified data, so that hospitals can release the data set. So we don't have something like HIPAA in Korea. So even if we build K-mimic, it probably won't be downloadable. It probably won't be able to go outside the hospital network. So which is very unfortunate. The reason for building K-Mimic should be to freely open or release private data or electronic health records. So as to encourage new innovation, new startups, new research, or whatever. But if it can't leave the hospital network, I'm not sure what we're doing actually. It's very against the original motivation. So I think since it won't be able to, since hospitals or anyone who's doing this project, the K-Mimic project, they probably won't allow external users to download the CSV files. They probably will be uploading the EHR data on cloud, like Naver cloud or Amazon AWS cloud. Maybe not AWS, because AWS is an international country, so probably Korean government don't want Korean EHR datasets to be uploaded on Amazon AWS. Is K-Mimic going to be in Korean language only? I'm afraid so. So I keep claiming that K-Mimic should be in English, so that anyone in the world, like any international researchers or students, can use K-Mimic, and that is actually what the objective of K-Mimic should be, to open source Korean EHR dataset so that anybody in the world can access it and then get familiar with it, and then hopefully do some research that might be beneficial to Korean hospitals. But I'm not sure if I'm not sure if people are willing to translate EHR data into English. As I said, there are some open source datasets like Amsterdam Health EHR or Brazilian EHR, but as I said, they're in Portuguese or Dutch, so like people don't really take interest in those datasets. If we release K-Mimic only in Korean, I don't think anybody will take interest in that. I mean, except for Korean people. So what I'm saying is that like translating the actual values in the table, that could wait, but at least the manual, the user manuals, the table names, the column names, those should be translated in English. So that's what I keep saying, but we'll have to see. Anyway, so as I said, the K-Mimic will most likely be on the cloud. So as probably Naver cloud or Kakao cloud. So what would happen? It's just something for like food for thought, something that we could have a short discussion. So what would happen if data cannot leave the cloud? Like, for example, let's say that someone who's like a cloud vendor, like Kakao or Naver or whoever, it could be like anyone. I think a lot of IT companies are trying to be a cloud vendor. Even the telecommunications company like LG Communications, LG Telecom, U Plus. I'm sorry, yeah, U Plus. I think U Plus has cloud, and maybe KT has cloud or SK has cloud. Anyway, so what would happen if some vendor became is chosen to be a cloud, like an official cloud vendor for K-Mimic, and the data cannot leave the cloud, so nobody can download the data, but can only access the data or explore data on the cloud? What would happen? So data exploration. So if we want to take a look at the data, we will have to create our account on that cloud and then take a look. So right now, for Mimic 3 or Mimic 4, whichever, for anything on PhysioNet, you can just create an account on PhysioNet and then just take a look. Especially Mimic 3, they actually have a free service where you can, query using SQL, which is a very admirable thing, because it's free. Like, somebody has to run the SQL server in order to freely service to the world, but like it means that if we can do it, somebody's doing it for free. So that's very admirable. So anyway, so data exploration, that must be on the cloud. Data processing, of course, that must be on the cloud. So if nobody can download the cloud, but you want to somehow take a look at count something or count some statistics or whatever, then you need to write your code maybe somehow upload it on the cloud and then run it. And if, for example, let's say that you used Python code to do some pre-processing, and unfortunately the cloud doesn't have the Python interpreter, then you can't actually run your Python code. It's very unlikely that the cloud won't support Python, but it's just like a hypothetical scenario. Like it has to, you write some code on your local server and then try to replicate that on the cloud, and the cloud environment and your local environment is different or incompatible, then it's not going to fly. So that's another issue. Training machine learning models. If you can't download the data from the cloud, but only you can run things on the cloud, then you will have to train your model on the cloud as well. So hopefully, if you are familiar with PyTorch, then hopefully cloud will support PyTorch so that it can run your code. So again, a lot of limitations, a lot of restrictions are there if the data cannot leave the cloud. And additionally, if you want to train your machine learning models on the cloud, then you probably have to pay for the service, pay for the GPU resources, which is not cheap usually. So yeah. And also deploying the machine learning models. So let's say that you've trained your machine learning model on the cloud, paying a lot of money, and then you finish the training and you have the parameters, and you want to deploy it on your local server. So then you'll have to download that the trained parameters. You'll have to download so that you can copy that to your local server, and then you can do whatever you want in your local server. So if that is, I mean, that must be allowed, right? Like if user cannot download the data set, but then they must be able to download the trained model, right? So what would happen is that completely okay? Is that completely secure? If people cannot download the data set, but can download the trained ML models, is that completely secure? Would that completely protect the privacy? Are there any risks? Anyone care to guess? 그러니까 데이터는 다운을 못 받더라도 그 데이터를 이용해서 학습된 모델을 다운받을 수 있게 해준다면은 그거는 할까요? All right, no takers. 그렇죠. 최우성님, 아주 좋은 대답입니다. 오버피팅 심하게 된 모델. So yes, 데이터 유출할 수 있는 것뿐만 아니라 사실은 so that what 우석채 said is that if you train a model which is like heavily overfit, then you can probably re-engineer or reverse engineer the models so that you can infer something about the data. But even more, we can go a little further. We can actually train a generative model like GANs or VAEs, and then download that model on the local server, and then you can just generate the data, which is most likely the real data actually. So if you have a very overfit GAN, then you can reconstruct the data, or actually you can just train a autoencoder, which is basically just a compression model. And if it's heavily overfit, you can download the autoencoder and then just reconstruct. So that, yeah, so just simply blocking people or preventing people from downloading the data set is not enough. You will have to really think about how to manage the trained ML models. Like, so yeah, I think K-Mimic has a lot of issues, underlying issues, and sooner or later we'll have to all discuss how to manage the entire project. All right, moving on. So that was honorable mention K-Mimic. today's topic. So it's from this week, we're going to talk about how to build a predictive model based on EHR, and for maybe a couple of weeks, and then after that, we're going to talk about the first project, which is mortality prediction, or it could be actually readmission prediction, but that's fine. I mean, anything simple enough to predict based on EHR. So that will be the contents of the project. So starting from today, we're going to take a look at the prediction models. So task is, so the things that we're going to talk about today is hospital readmission prediction and ICU readmission prediction. So both are readmission prediction. So we're going to talk about why they're important. And the data, if you have like a goal, then you need to actually pre-process the EHR. So because they're unlike computer vision or NLP, like computer vision, there's ImageNet data set where everything is already pre-processed. So all you need to do is just download the data sets, and then you can train whichever model you want to train, ResNet, WideNet, whatever. You can just DenseNet, whatever. You can just select your model and then just feed already a clean data set into the model to just optimize the model. But or same thing with NLP. If you have a squad data set, you have you have a lot of NER or POS taking data. Yeah, there's already like tons of data. But the EHR data set, there aren't a lot of, or maybe none, zero, almost virtually zero pre-processed data sets. Because to begin with, EHR data sets are hard to access. You need to go through all the city training and all that in order to get your hands on EHR. And then you'll have to pre-process on your own. So, I mean, already researchers have already gone through projects to do readmission prediction or mortality prediction. So they have their own pre-processing code, which I did as well. So when I was doing my PhD, I always uploaded my pre-processing code, which was written in Python, on GitHub so that other people could replicate my work. But there is no like one, like, central universal data sets for mortality prediction, or there is no like one data set used by everyone for readmission prediction. So yeah, you most likely you'll have to do it on your own. And it's actually better that you do it on your own, because so as to get better understand the EHR. So anyway, so data processing is one of the fundamental aspects of EHR, building predictive model on EHR. We'll go through we'll select one readmission prediction example and then just go through go through the entire pre-processing steps, which will be workflow examples. We'll briefly talk about MapReduce, which is, if anybody is familiar with Hadoop or MapReduce or Spark, MapReduce is a very familiar concept to them. But if not, we'll just briefly cover this. And then we'll go to the modeling part. So the classical approach, which is usually using logistic regression or random forest or support vector machine. So logistic regression is still it's like a go-to method in a lot of biomedical research, because the model itself is it's a very simple model, and it's a linear model. And given logistic regression or linear regression, you can do a lot of statistical analysis, like confidence tests or that kind of coefficient analysis and that kind of stuff. And then we're going to go to a deep learning approach. All right, so we'll start with the tasks. So hospital readmission prediction. So task 1. So goal is, given the current hospital visit, predict whether the patient will return to the hospital again in 30 days. So please you need to really understand what this means. Given the current hospital visit, so I'm in the hospital right now, and then as a patient, I'm admitted to the hospital, and then given my records so far, predict whether the patient, which is me, will return to the hospital again in 30 days if after discharge. So I think I briefly mentioned why this is important, but we'll actually take a look at this. So why does it matter at all? Why is readmission prediction just a worthy task at all? Because it doesn't seem like as important a thing as like mortality prediction or diagnosis prediction or drug recommendation. But actually, so there is something called CMS Hospitals Readmissions Reduction Program. So I'm just going to go to this link. Oh, actually, I need to reshare my screen. Right. So this is CMS. So CMS.gov. This is short for Centers for Medicare and Medicaid Services. So CMS is like a 건강보험원 of the United States. So as I said, United States, they don't have a centralized insurance policy. So 한국은 이제 의료 국민 건강보험이 있는데 미국은 그런 게 없잖아요. So unlike Korea, where we have 국민 건강보험, where everybody must be insured, it's a mandatory policy. So even if you're not interested in the Korean centralized government, Korean centralized insurance plan, there's no other choice though. You still have to be a member, so which is kind of a good thing for the people, not so good for the hospitals and the doctors. But unlike Korea, so in the United States, there is no centralized insurance plan. So you're on your own. So you have to buy your own insurance policy from like private vendors. So there are a lot of insurance companies in the United States. But for those who are really old, not really old, for those who are over 65 years of old, so seniors who are 은퇴하신 분들, who have retired, for them, there's a government-run insurance policy, which is, I think, Medicare. I'm not sure which is Medicare and Medicaid. I'm not sure which one is which. I actually. Yeah, okay, it's Medicare. So yeah, so Medicare is for people who are over 65 years of age. So who are retired, they are officially out of the job market. So it's unreasonable for them, for you to expect the seniors to get a job to maintain their insurance plan. So the government is handling that. So that's Medicare, and Medicaid is for those who are like, who are in the like a lower income spectrum, so who earn like really small amount of money per year or per month, like the poor people. So that's for Medicaid. So if you're really poor, obviously you don't have enough money to buy your own private insurance plans. So that for them, the government is actually supporting them. So Medicaid is, I think Medicaid is the Obamacare. So yeah, when President Obama was elected, one of the main goal or objective was to do implement Obamacare for the underprivileged people. So CMS is a government entity that runs both Medicare and Medicaid services. So it's exactly like 건강보험원. So they, of course, as a government entity, they want to minimize, or they want to somehow at least decrease the expenses going into the Medicare and Medicaid services. So they need to like come up with ways to either use new technologies or just do some great management or whatever. So find some innovations to spend less money to run Medicare and Medicaid services. So which is the same problem in Korea. 건강보험원은 이제 어떻게든 돈을 아껴가지고 똑같은 레벨의 이제 어떤 서비스를 하고 싶잖아요. 그 예산을 줄이면서 어떻게 하면은 똑같은 레벨의 서비스를 하냐, 어떻게 하면 이제 최대한 많은 사람들한테 건강보험을 돌릴 수 있겠느냐, 이제 이런 걸 항상 고민을 하겠죠, 건강보험원은. 그리고 그래서 이슈가 많이 되죠. 외국인한테는 보험해주지 말아라, 그런 얘기 많이 하잖아요, 인터넷에서 사람들이. 그런 이슈가 이제 CMS에도 있습니다. So as I said, so CMS is very interested in how to decrease the expenditures, and one of the ways is actually, it's called, one of the plans or ideas was implemented in the name of Hospital Readmissions Reduction Program. So this is exactly what it says, to reduce hospital readmissions, and that's it. So there's something called value-based value-based purchasing program. So value-based is like usually when you go to the hospital, you pay for the services. Like if you took an X-ray, that's like some amount of money. If you were prescribed for some drugs, then that's like that equals to some fee. If you went into surgery, that amounts to some fee. Like there's like fee for services, like fee for like there's service-based purchasing. That's the service-based purchasing, or item-based purchases, item-based purchasing. Like if you got some service, you pay for that amount. But value-based is something like if you got better after the service, like whether like comparing when you entered the hospital, when you left the hospital, if you got better, then that's like that, then you pay amount of money. So that's kind of like the idea behind. It's not exactly that, but it's something like that. So value based is like that. So they want, so if you just if you maintain, or if the hospitals charge you for the service based purchasing, then they might actually, in order to increase revenue or income, they might over service. They might recommend or apply like unnecessary services to, charge you a lot of money. Well, not in Korea. So it's in Korea. Well, like if you, let's say that you go to the hospital and then you have a broken bone on your arm, but let's say that the hospital just for the sake of sake of making claims to the 건보 심평원, they just take an X-ray on everywhere. Like they could say, okay, so you have a broken bone, but you might have a broken bone. You might have you have broken arm, but you might have broken bones somewhere else, like maybe your arm, your legs, or your necks, or your shoulders. So let's just take X-ray everywhere, and then you have like a lot of X-ray services on your bill. Then it's not necessarily bad for you because you're insured, so you don't pay a lot of money. Even if you go through a lot of like procedures or labs or surgeries, you don't pay a lot of money because you are insured. But the government must reimburse the hospital for all those services. So it's the government that usually loses the money, or especially the 건보원. So in order to prevent that kind of behavior, so the government wants to somehow guide the hospitals to do exactly what's necessary, right? And another thing is that they, as I think I've said this before, but hospitals usually want to discharge the admitted people as soon as possible. 그러니까 입원한 사람들을 최대한 빨리 퇴원시키고 싶어요. 그래야지 이제 또 병상이 비고, 그래야지 또 입원을 또 새로 받을 수 있고, 그래야지 또 이제 이 인컴이, 이 레비뉴가 늘어나고. 그러니까 한 사람이 이제 다 아프지도 않은데 계속 그냥 병상을 차지하고 있으면은 새로운 아픈 사람을 못 받아들이잖아요. 그럼 이제 뭐 여러 가지로 안 좋겠죠. 서비스도 못 하고, 또 뭐 돈도 안 늘어나고. 그러니까 이제 당연히 이제 병원 입장에서는 최대한 빨리 이제 아프지 않은 사람들은 빨리빨리 내보내고 싶은데, 그러다가 이제 또 다 완치가 안 된 듯 내보내가지고 이제 잘못되는 경우가 많으니까, 이제 그거를 막기 위해서 이제 요런 Hospital Readmission Reduction Program을 이제 implement를 합니다. So this program is to encourage hospitals not to discharge untreated or unhealthy people too early, so that they end up back in the hospital within short amount of time, which is 30 days in this case. So CMS includes the following 6 conditions or procedure specific 30-day risk standardized unplanned readmission. So if some patient was admitted to the hospital, so 요런 걸로 입원했으면은 뭐 폐렴, 심부전, 요건 이제 호흡 쪽인데, 이 뭐예요, 이 COPD라고 그러는 건데, 만성 이 무슨 폐 질환인데, 뭐 그거, 그다음에 이제 그 acute myocardial infarction이 뭐예요? MI라고 하는 건데, MI. So yeah, anyway, so these are all very, very like chronic, very critical diseases, all related to cardiovascular symptoms. So myocardial infarction, which is related to heart. This is related to pulmonary, so which is related to your lungs, heart, lungs, again lungs, and this is arthroplasty. This is 요거 이제 무릎 관절 쪽 관련된 뭐 그런 거네요. 네. So if some patient was admitted to the hospital for one of these 6 reasons and was discharged too early, so that they end up back in the the hospital within 30 days after discharge, then the hospital is not going to pay the government is not going to, they're going to penalize the hospital financially, basically. So they're not going to like reimburse like 100% amount of the claimed bill. So basically you can understand that if somebody went through this and then was discharged and then end up back in the hospital 30 days, then the hospital loses money. So that's basically the spirit of HRRP. So because of this was implemented back in 2012, if I'm correct. Yes, here. So yeah, this program was beginning in October 2012. So it's still ongoing. So it's been 8 years or 9 years. So because of this, readmission, like properly discharging the patient and then so that they don't end up back in the hospital within 30 days has become a very important thing in the hospital in the United States. So we definitely need a readmission prediction model. So when the hospital decides to discharge a patient, then they run this model. They apply this model on the patient record and try to estimate whether this patient will end up back in the hospital within 30 days or not. So this is actually related to a lot of money. Right, so the inclusion exclusion criteria. If you want to predict something based on EHR, you always have to think about inclusion exclusion criteria. So you have, for example, in Mimic3, you have about 40 something ish number of patients in the data set. And when you want to do hospital readmission prediction, it is not a good idea to include everybody in the data set as a training set. In the training data. So you want to carefully choose who are eligible to be included in this study. So there's a lot of criteria. So based on these criteria, you want to choose who are eligible, who are like fit for a training data and who are not fit for training data. For example, readmission prediction. It is probably not a good idea to include neonates in the data set. Neonates being 신생아. So 신생아들을 이 readmission prediction용 데이터셋에 넣는 게 그렇게 의미가 없을 수도 있겠죠. 왜냐하면 아까 보셨듯이 이제 readmission prediction 보통 심혈관 질환 쪽에다가 이제 주로 이 초점이 맞춰져 있는데 심혈관 질환은 주로 이제 나이 드신 분들, 장년층들이 걸리시니까 신생아들 여기 신생아들 대상으로 이런 걸 readmission prediction 할 일이 별로 없겠죠. So again, so yeah, so there could be a lot of criteria. So age, sex, condition, medication procedures. Like I'm gonna choose patients between age of 18 to 65, and I'm gonna choose both male and female, but I'm gonna keep the balance to 50-50, something like that. And I'm gonna choose patients who have gone through certain conditions like myocardial infarction or heart failure or hypertension or whatever. Like you are interested in some group of patient. 그러니까 이제 이 readmission prediction 할 때 나는 심혈관 질환을 한 번도 안 겪은 사람을 대상으로 하고 싶다. 또 겪은 사람을 대상으로 하고 싶다. 이런 것들 이제 다 설정을 하셔야 됩니다. So the same goes for medication. You're going to filter out patients who had been prescribed certain medications or who had been prescribed who have not been prescribed certain medication. And procedures like who went through surgery or who didn't go through surgery. That's also a thing. So 요게 이제 이 inclusion exclusion criteria는 이제 아주 많이 씁니다. So this is a very widely used concept, especially in randomized clinical trials. So 임상 실험할 때도 이게 굉장히 중요하죠. 이제 항암제 같은 걸 임상 실험할 때는 누구를 이제 선발할 거냐 병원에서. 이제 항암제니까 당연히 암 환자들을 대상으로 해야겠죠. 그래서 이제 누구를 선발할 거냐, 그다음에 선발할 사람들의 어떤 프로파일들, 유전자의 어떤 유전자적 구조, 유전자 특성 또는 어떤 나이적 특성 아니면 이제 그 전에 어떤 항암제를 먹은 적이 있냐 없냐 이런 것들 굉장히 따져가면서 이제 이 임상 실험의 대상으로 선발을 합니다. So what I just said is, for example, if you're doing clinical trials, in pharmaceutical companies, if they're doing clinical trial for like cancer drugs or cancer medications, then they have a very, very like a rigorous set of criteria. And usually diverse criteria. These criteria are not prepared by us being AI engineers or AI researchers, they have no idea what are important criteria and what are not. So it's usually established or defined by medical experts like doctors or epidemiologists or pharma like biostatisticians or anyone who's working at pharmaceutical companies. Like they are the ones who decide this criteria, and then as an engineer like us, we can just implement that in the code. I think there was a chat. 진원님, 네, 그렇죠. 이 부분은, 그러니까 이제 이거는 사람의 전문 지식이 중요합니다. 그러니까 이제 약을 아까 말씀드렸듯이 이제 항암제를 제약을 한다 그러면은 또 어떤 계열의 항암제냐, 이게 뭐죠? 이게 뭐 백금 계열이냐, 무슨 계열이냐, 이제 항암제도 계열들도 있거든요. 그럼 뭐 이제 그 항암제를 임상 실험을 한다. 그러면 이제 같은 계열의 항암제를 먹어본 사람은 빼고 싶다던가, 뭐 그런 다양한 어떤 이제 굉장히 많은 백그라운드 지식과 이런 게 필요해서 특히나 이제 우리가 할 것 같은 이제 Readmission Prediction 사실 뭐 이게 뭐 그렇게 어려운 건 아니니까 우리도 뭐 대충 그냥 뭐 몇 살에서 몇 살 사이 뭐 어떤 병을 겪었고 이제 뭐 최근에 최근에 병원에 왔던 사람 뭐 이런 식으로 간단하게 할 수 있는데, 항암제다 그러면은 굉장히 이제 그쪽 분야의 전문가만이 전체적인 임상 실험을 디자인할 수가 있어요. 이제 이거를 그것도 이제 초보자 의사 선생님이나 얼마 안 된 그런 분들도 못하고, 이제 그 분야에서 오랫동안 제약회사에서 일을 해왔다던가 이제 아주 그 분야의 전문가라던가 그런 분들과 같이 여러 명이서 이제 같이 팀을 꾸려가지고 임상 실험 자체를 디자인을 합니다. 그래서 이런 거는 아직까지 기계학습으로 하기는 어렵다. 네. 사실 근데 또 이제 이 인터넷 웹사이트 중에 이것도 제가 잠깐 보여드릴 수 있을 것 같은데. So what Jinan Che asked is, so this setting this inclusion exclusion criteria, so that probably requires a lot of like expertise or domain knowledge, and the answer is yes. So as I said, if you're doing a clinical trial, there's like a whole team who designs the inclusion exclusion criteria and how to run the entire clinical trials, like because there's like first stage, second stage, third stage, like 1상, 2상, 3상 이런 거 있잖아요. 그런 것처럼 이제 그런 거를 뭐 몇 번 할지, 언제 할지, 뭐 누굴 대상으로 할지 이런 거 다 이제 디자인하는 사람들이 있는데, so but there might be a way to actually train a machine learning model to come up with a design, like a clinical trial design, because there is a whole website dedicated for clinical trials, so which is clinicaltrials.gov as shown here. So in this website, you can look for clinical trials that has been going on since, I don't know, like probably several decades ago. So far, there are about 370,000 studies, clinical trial studies that has been going on in 50 states in 219 countries. So it's not just like United States, like in a lot of like international. So it's an international collaboration. So there must be clinical trials that has been going on in Korea that is like part of this website as well. So let's say that you are recruiting and not yet recruiting studies, all studies. We're just going to look at all studies. Small cell lung cancer. So 이게 비소세포 폐암이죠. 우리나라 말로 하면은. Actually, non-small cell lung cancer. Platinum. Country. Let's see if there's South Korea. Korea. I'm not sure if North Korea is doing clinical trials. City. We're just going to search for everything. Right, so let's see. So status unknown, status completed. So I'm not. So yeah. So some medical. I don't think we need it. Yeah, clinical trials done in Samsung Medical Center. 삼성병원에서 한 거죠. 그래서 삼성병원인 건데. Pemetrexed. And I think these are drug names. Pemetrexed. Gefitinib. in never smoker and adenocarcinoma patients. 이제 아데노카르시노마면 뭐죠? 아데노카르시노마. 선암이 뭐야? 선암. 그러니까 이제 한 번도 평생 한 번도 흡연을 하지 않은 사람들과 이제 선암 환자들 대상인데 이제 그러니까 이제 이 비소세포 폐암을 걸린 환자들 중에 이제 한 번도 폐암을 걸린 한 번도 스모킹을 안 했고 선암인 사람 대상으로 이제 이 백금 계열의 이 키모테라피 이제 이 항암을 했을 때 이제 뭐 얘네들의 어떤 그 뭐 효용성 이런 걸 본 그런 실험이라고 보실 수 있습니다. So yeah, a lot of hospitals are like a lot of different hospitals, like Samsung Medical Center, 경상 National University, 경상대학교죠. Southern 이건 요거는 이제 여러 나라가 했나 보네요. 여러 나라가 하고 아산병원에서도 하고, 네, 아산병원에서 하고 비슷하네요. 페맥트렉스는. 요거를 눌러볼까요? 이걸 눌러보면은 이제 여기에 이제 굉장히 많은 정보가 있어요. There's a lot of information that someday we might be able to exploit as a machine learning researcher. So there's a bit of like a semi-structured data here. So study type, interventional, estimated enrollment 130 patients. So 130명 정도가 이제 클리니컬 트라이얼에 들어간 거죠. 임상 실험에. 그다음에 인터벤션은 뭐 이제 어떻게 한다. Official title. Study. So it had started in 2008 and then had ended in 2010. 거의 뭐 10년도 더 됐죠, 한지. 여기 보시면 이제 eligibility criteria가 있어요. 이제 이게 inclusion, exclusion criteria인데 보시면은. So ages eligible for study, 18 years or older. So we don't, in this study, children are not included. Sex is eligible, so both male and female, okay. Accepts healthy volunteers, no. So 이거는 이제 딱 그 아픈 사람들만 대상으로 하는 이제 임상 실험입니다. 이거 보시면은 이제 there's inclusion criteria, exclusion criteria. So one inclusion criteria. So yada like a pulmonary adenocarcinoma. So 선암에 걸렸던 사람들. 뭐 이제 stage 3B, so malignant pleural effusion. Stage 4. 이제 굉장히 이제 아픈 lung cancer 중에서도 이제 정말 뭐 3단계나 4단계쯤에 있는 이제 이미 뭐 다 여러 몸에 퍼질 대로 퍼진 분들, 그런 분들을 대상으로 한다. 그다음에 이제 failed with first line platinum based chemotherapy. 이게 이제 한 번 키모테라피 이제 이 백금 계열의 키모테라피를 한 번 했는데 이미 말을 안 듣니까 보통 이제 뭐 내성이 생긴다고 하잖아요. 암세포 항암을 해도 이제 1차적으로 이제 가장 뭐 많이 쓰이는 백금 계열의 항암을 했는데 이미 내성이 생겼다. 그래서 이제 이미 failed with first line. So this means that there's so the lung cancer, the cancer cells have already became resistant to the very most widely used platinum-based chemotherapy. So these are the people. So if that happened to this, so the patients who have gone through that process, they're eligible for inclusion, being included in this data set or in this study. Should never have smoked, 18 years or older, ECOG, not sure what this is, maybe some lab test or whatever. Anyway, these are the inclusion criteria. Exclusion criteria is, so if you have a symptomatic brain metastasis, so if metastasis가 이제 그 암세포 전이 된 거니까 이제 뇌로 전이가 됐으면은 여기에 끼면 안 된다. 이 임상 실험에 들어가면 안 된다. 네, 그다음에 뭐 EGFR 계열의 뭐 어떤 걸로 이제 이미 항암을 받았으면 들어오면 안 된다. 그다음에 이제 뭐 요런 걸로 또 뭐 이미 처방을 받았으면 안 된다. 그다음에 입으로 뭘 할 수가 없으면 이게 뭐 입으로 먹는 약인가 보네. 이제 입으로 뭘 할 수가 없으면은 이제 뭐 들어오면 안 된다. 뭐 그런 거고 뭐 이제 이미 감염이 돼 있다. 뭐 예를 들어서 뭐 뉴모니아, 뭐 폐렴이나 뭐 결핵이나 이런 거에 감염돼 있으면은 이제 안 된다. 뭐 그런 거입니다. 네. So there are, as I said, 370,000 clinical trials, and every clinical trials, they have the criteria. So if you use this and the study description, and maybe there's somewhere in here there's like objective or whatever, then you can use that as a training data set. And then maybe if you enter this brief summary, then the machine learning model might be able to generate a set of inclusion exclusion criteria. I think there's already an ongoing ongoing research in this aspect. There, I've seen automatic patient recruitment research for clinical trials as a research topic. Okay, so a question. 방금 예시처럼 임상시험 실험자 참여자를 100여 명 내는 학생이 충분하지 않을 텐데 단순 어그멘테이션 커버하기 힘들 것 같다는 생각이 듭니다. 보통 임상시험 학생이 뒷면이 많이 있어요. 그러니까 제가 말한 그 임상실험은 이 사람들 이제 뭐 이 사람들을 어그멘테이션 한다는 게 아니라 이거 자체를 자동으로 만들어 준다는 거예요. 이 크라이테리아, 인클루전, 익스클루전 크라이테리아를 원래는 이제 이 정말 도메인 널리지가 있는 사람만 이거를 만들 수가 있는데 이제 이거를 머신러닝을 해서 우리가 여기다가 우리가 하려는 실험이 뭐다 여기 있으면 이제 실험 내용이 있잖아요. 이제 뭐 페맥 트레세드를 가지고 뭐 이제 우리 뭘 인베스티게이트 할 거다. 뭐 얘네들이 이제 뭐 효과가 있냐 없냐 이런 거를 인베스티게이트 하고 싶다라는 이런 내용을 모델한테 넣어주면 텍스트로 그럼 걔가 알아서 이제 뚜루룩 하고 얘들을 이제 그러면은 뭐 요런 인클루전, 익스클루전 크라이테리아가 있어야 됩니다라는 걸 이제 생성을 해준다면 그런 모델을 생각해 볼 수 있겠죠. 지금 실험 이 클리니컬 트라이얼 개수가 한 37만 개쯤 되니까 뭐 해볼 수 있겠죠. 그런 걸 얘기한 거였고요. 성진님 얘기하신 거는 그 이제 애초에 이 실험 이 100명을 대상으로 얘네들이 이제 효과가 있겠냐 없겠냐 그 자체를 예상하는 거면은 당연히 이제 129명이면은 적죠. 그래서 그거에 대한 그거를 뭐 불리는 실험은 잘 모르겠어요. 있는지. 이게 사실 이 임상실험이라는 게 굉장히 민감해서 요거를 가지고 제약이 이루어지고 여기를 통과한 약은 정말로 마켓에 이제 정말로 이게 팔리고 병원에서 사용되는데 이 임상실험 자체에 이제 어떤 에러의 확률이 있는 머신러닝을 쓴다는 것 자체가 굉장히 위험하거든요. 임상실험 하나인데 막 몇 조씩 뜨는데 이거 막 뭐 머신러닝 함부로 썼다가 문제가 있었다가 이제 몇 조 날리면서 다 리콜 전량 리콜 들어가고 이렇게 되는 거라서 아직까지는 이렇게 막 그 액티브한 막 적극 공격적으로 머신러닝 모델을 뭐 써가지고 이 약의 효과를 예측한다거나 이런 거는 굉장히 저는 좀 위험하지 않나 생각을 합니다. 그래서 주로 이제 제약회사들이 머신러닝을 갖다 쓰려는 거는 제가 이제 요 수업에서 나중에 다룰 거지만 드럭 디벨롭먼트 이제 제약 자체를 이제 어떻게 하면은 돈을 덜 들이고 하겠냐 이런 쪽에 이제 쓰려고 합니다. 이제 뭐 그래프 뉴럴 네트워크나 이런 거나 버트 같은 거 이용해서 이제 화학 구조식 같은 걸 막 넣어준 다음에 어떤 화학 구조식이 효과가 뭐 어떤 병에 효과가 있겠냐 이제 이런 걸 이제 캔디데이트 셀렉션 하는데 이거를 좀 뭐 속도를 빠르게 한다던가 아니면 조금 더 효율을 높인다던가 이런 거에 이제 하려고 제약회사들이 좀 관심이 있어요. 그럼 이제 옛날 같으면은 막 10,000개를 뭐 이제 대충 요 한 10,000개 정도가 효과가 있을 것 같다. 그럼 10,000개를 막 임상 실험을 동시에 돌리는데 그게 아니라 머신러닝으로 딱 한 100개 정도를 추릴 수 있으면 이제 100개가 임상 실험 돌리면 실험 뭐 돈이 100분의 1로 줄은 거니까 비용이. 그래서 이제 그런 쪽에 이제 관심이 있습니다. 네, 답이 되셨으면은 네. All right, so as I said, so inclusion exclusion criteria is very, very important. And so far it is being defined by the experts, but maybe someday, if you guys are interested, you could actually start this as a research topic, you know, how to, so it would be like an encoder decoder approach, or maybe not encoder decoder or encoder decoder, because inclusion exclusion criteria is a text. So in the encoder, you put this in the encoder, and then on the decoder will generate, maybe there's like inclusion decoder and exclusion decoder. So two decoders will generate a set of like a criteria or set like a bulk of text. So, yeah. Anyway, yeah, there's a lot of things to be done in healthcare. All right, moving back to the slides. All right, yeah, we've actually spent a lot of time in this preliminary stuff, but this is, yeah, when you actually, so the first project, you will have to understand the inclusion exclusion criteria and then implement the code to filter out or filter in necessary or unnecessary patients. So this is a very fundamental concept. So I hope everybody has a clear understanding of why this is all like important. All right, so so in hospital, so back to the hospital readmission prediction scenario. So there are a lot of scenarios. So first, let's say that this this is patient number 1, and we want to do hospital readmission prediction based on this record. So for this patient number 1, all we have is this record. So on 2009 January 2nd, this patient was admitted to the hospital. So 입원을 한 거죠. 그다음에 2009 January 3rd, this patient went into the ICU room or intensive care unit. 이게 중환자실로 이제 하루 있다 들어간 거고, 저번 주에 보셨죠, 이런 패턴. 중환자실에 들어가고, and stayed there for 8 days, and then was discharged from the ICU on the 11th of January. So 이제 8일 정도 중환자실에서 이제 계속 집중 케어를 받다가 이제 괜찮아졌다 싶어서 중환자실에서 나오고 11일에. 그다음에 이제 on the 12th of January, the patient is completely discharged from the hospital. 이제 아예 이 ICU에서 나와서 하루 정도 더 지켜보고 상황을 12일에 퇴원을 시킨 겁니다. 그래서 여기 이제 hospital discharge죠. So so given this record from the MIMIC3 dataset, based on this information, will this patient visit the hospital again in 30 days? So we want to build a training set for this task. We want to build a training set for this task. So we need a positive example and negative example, because this is a binary classification. Predict whether the patient will return to the hospital again in 30 days. So this is just simple yes or no question. So it's a binary classification. So we need training set including positive cases and negative cases. So true or false. So given this data set, can we use, so which case is this patient? Is this a positive case or negative case if we are to use this patient in the training set? So the answer is obviously no, because 30 days after the discharge from the hospital, which is February 22nd. So there is, until February 22nd, there is no hospital admission again. So there's nothing here basically. So there's nothing here. So this patient is basically a negative case. So this patient did not end up back in the hospital within 30 days. So this is a negative. This is a control patient basically. How about this guy? So based on this information, will this patient visit the hospital again in 30 days? So should this patient be a positive patient, like a case patient, or control patient? So within 30 days. So this patient ended back up in the hospital at January 25th, which is within the 30-day time frame. So this patient is a positive patient. This is a case patient. So in this case, we're going to use this patient as a case patient. So in both cases, here, we're going to use this record, this entire record, as our feature, or the X, because what we're trying to do is we're trying to predict Y, which is the whether this patient ends up back in the hospital within 30 days or not. So Y given X. So this is a conditional probability. This is a conditional prediction basically. It's a discriminative prediction. So predicting Y given X, and that X should be this entire thing. And again, for this guy, we're going to use this entire information and then try to predict this information, this yes, positive label. How about this guy? So this guy went into the hospital, went into two ICU rooms for 2 consecutive times, and then discharged, and then went back into. So what's important is not so. Important thing is what happens after the discharge, within the hospital admission, whatever happens, whether this patient is admitted to the ICU, is not admitted to the ICU, or visits the ICU like 5 times or 10 times or 100 times. Doesn't really matter. What's really important for the label selection is that this patient, whether this patient ends back up in the hospital or not, and especially in this case, February 25th is not within the 30-day time frame. So this case is no, obviously. So we should use this information to correctly predict no. How about this guy? So this guy, 3 admissions in total, and on this, if we are to treat this as the X feature, and then try to predict whether this patient is readmitted. In this case, February 25th, So this is a no. This is no. But if we are to use this information, and try to predict readmission, then in this case, March 21st is within the 30-day time frame after this discharge. So this, in this case, this is a yes. So even with the same patient, we could extract, or we could construct two training samples. So two training samples with different outcomes. So if we are to use this information, then if we were to use this time step or this window, then the outcome would be no. But if we use this time window, the outcome would be yes. I think there was a question. HRRP로 인해서 병원 입장에서는 예측보다 30일에 리드미션 환자다 그럼 퇴원시키고 더 치료하는 게 목적인가요? 그렇죠. 네. 이제 HRRP의 목적 자체는 사실 Readmission Prediction 모델하고 상관이 없습니다. 그냥 HRRP는 이제 그 미국의 CMS, 그러니까 이제 건강보험원에서 함부로 사람 이렇게 빨리 퇴원시키지 말고 충분히 이제 다 트리트할 때까지 놔둬라라는 의미에서 이제 시킨 거고, 근데 이제 병원의 입장에서는 어쨌든 그러면은 이 사람을 퇴원시키는 게 좋냐 나쁘냐를 판단해줄 기준이 뭔가가 있어야 되잖아요. 이제 이거를 뭐 물론 의사 선생님이 보고서 요 정도면은 이제 퇴원시켜도 30일 이내에는 안 올 것 같다라고 이제 판단을 해도 되지만, 뭐 AI라는 기술이 있으니까 이제 머신러닝 모델을 이용해서도 그런 걸 한번 예측해 볼 수 있다는 거죠. 그래서 만약에 예측 모델 성능이 아주 좋다, 그러면은 이제 그 예측 모델이 이제 위험하다, 뭐 30일 이내에 들어올 것 같다라고 하면은 뭔가 더 붙잡아 두고 추가로 뭔가를 이제 해보는 뭐 그런 전략을 생각해 볼 수 있겠죠. 네. Right. All right. So that related to the question, which is a very important question. 지난 방문을 포함한 두 기관 모두에 기반해서 이후제. 그렇죠. 그것도 아주 좋은 질문입니다. 그러니까 이제 사실 여기만 가지고 판단할 필요가 없어요. 이거 다 가지고 판단을 해도 됩니다. 어쨌든 중요한 거는 요 시점에서, 요 퇴원 시점에서 이 사람이 30일 이내에 돌아올 건지가 중요하기 때문에 그 시점 이전에 모든 정보를 다 갖다 써도 돼요. 근데 이제 너무 많이 이제 10년 전의 정보를 쓰는 건 사실 의미가 없겠죠. 네. 그래서 뭐 그거를 이제 어떤 정보를 쓸 거냐, 그거 자체도 이제 도메인 널리지가 필요합니다. 이제 어떤 정보가 리어드미션에 중요하다 안 중요하다를 사실 이제 우리 같은 IT 엔지니어들은 모르니까, 이제 AI 하는 사람들이야 뭐 그런 걸 전혀 모르니까 이제 생리적으로 제2번, 특히 아까 보셨는데 이제 HRRP 자체는 이제 그 뭐 하트 페일리어, 뭐 뉴모니아 이런 심혈관계 쪽에 또는 뭐 호흡기 쪽의 질환에 관련이 있기 때문에 그런 거 엑스퍼티즈가 있어야지 요 상태면은 이제 뭐 30일 이내에 돌아올 것 같다, 아니면 이제 요런 피처가 이제 중요해서 요런 거를 잘 이용하면 모델의 성능이 높아질 것 같다, 이런 아이디어는 심혈관 또는 호흡기 쪽의 교수님들이 많이 아시겠죠. 그래서 그럼 이제 뭐 몇 년 전 거를 봐야 된다, 아니면 뭐 유전자 정보를 봐야 된다, 뭐 그런 것들을 알려주실 사람이 있어야 되는데, 언젠가는 이제 모델의 크기가 엄청 크고 뭐 GPU나 이런 것들이 뭐 엄청 싸지고 뭐 메모리가 무한히 커지면은 그때는 정말 모든 데이터를 다 넣어도 되겠죠. 마치 GPT-3가 인터넷에 있는 모든 텍스트를 다 넣었듯이 그냥 환자 한 명의 인생 전체를 모델에 넣어버리고 학습을 시키는 게 사실 제일 좋겠죠. 그게 사실 어떻게 보면 딥러닝의 정신이 제일 부합하고, 그러니까 피처 엔지니어링을 하기 싫다라는 게 딥러닝의 어떤 그 정신 중 하나인데, 그럴 거면 이제 알아서, 그러니까 우리가 빅데이터를 그냥 통째로 넣고 모델이 알아서 중요한 피처를 셀렉션 해주는 게 이제 딥러닝의 어떤 정신이라면은 이제 헬스케어 쪽도 그렇게 될 날이 오겠죠, 언젠가는. 그 사람의 뭐 모든 데이터, 모든 뭐 모든 방문 기록, 모든 카톡 텍스트, 모든 네이버 지도 검색 기록, 모든 구글 검색 기록, 그 사람의 어떤 뭐 유전자 정보 이런 걸 다 탈탈탈 털어 넣으면 사실 그 사람이 무슨 병에 걸릴지 굉장히 정확하게 알 수 있겠죠. 근데 그러면 이제 또 개인 정보에 대한 또 문제가 생길 수 있으니까 항상 그 딜레마가 있습니다. 헬스케어는 제가 생각하기엔 항상 딜레마가 있어요. 개인 정보를 많이 쓸수록 성능이 좋아지는데 그걸 이제 과연 용납을 할 것인가, 사회적으로 또 그 개인이, 항상 그런 문제가 있습니다. 예를 들어서 카톡 텍스트 전부 다 뭐죠, 이루다였나 걔처럼 카톡 텍스트 전부 다 넣으면은 그 사람이 어떤 최근에 뭐 고민이 있는지, 뭐를 주로 시켜 먹는지, 뭐 배민 같은 거, 특히 배민 기록 같은 거 정말 좋거든요. 그런 거를 모델에 넣는다. 맨날 치킨만 시켜 먹는다. 그럼 뭐 당연히 고혈압이나 뭐 고지혈증이나 이런 거에 걸릴 확률이 높겠죠. 근데 뭐 맨날 뭐 샐러드만 시켜 먹는다 이러면 이제 그 사람은 뭐 보험료를 깎아준다던가 뭐 이런 일을 할 수 있을 테고. 네. 그래서 그런 정보가 사실은 굉장히 꿀 정보인데 과연 이제 배민이 아니면 요기요나 쿠팡이츠가 과연 그런 거를 할 것인가? 저도 궁금합니다. 뭐 네이버 같은 경우도 네이버 쇼핑이 있잖아요. 그럼 쇼핑하면 이 사람 맨날 뭐 사는지 알 수 있거든요. 뭐 맨날 뭐 운동기구만 산다. 그럼 이제 뭐 훌륭하고 뭐 이제 맨날 뭐 먹을 거 뭐 이런 것만 산다. 그럼 이제 이 사람은 뭐 병원에 뭐 자주 가겠구나 알 수 있고 뭐 그런 거죠. 네. 그래서 이제 앞으로의 그 발전 방향은 무궁무진하다. 이제 여러분들이 인터넷에 함부로 남기면은 이제 그거 다 이제 피처로 써가지고 대기업들이 돈을 잘 벌 수가 있습니다. 메디케어, 메디케이드에 해당하는 환자들 대상으로 모델링하는 게 맞나요? 이 HRRP 자체는 사실 메디케어, 메디케이드 자체랑은 사실은 약간 무관하다고 봐야 되는데 일단은 맞습니다. 일단 이제 이 CMS라는 미국 건보원이 메디케어, 메디케이드만 운영을 하기 때문에 이제 뭐 다른 일반 환자, 그러니까 이제 시니어 환자나 아니면 뭐 저소득층 환자 외에 대해서는 HRRP에 대해 강요를 할 그게 없겠죠. 왜냐하면 이제 CMS라는 거는 그러니까 메디케어, 메디케이드 환자가 병원에 가요. 그 다음에 이제 돈을 조금 내고 서비스를 받으면 그 병원은 이제 남는 분량을 그러니까 예를 들어서 뭐 100만 원짜리 수술을 받았는데 노인이 뭐 10,000원만 받고 그러면 이제 99만 원을 CMS에다가 이제 청구를 한 거거든요. 병원 입장에서는. 이제 CMS는 이제 그거를 체크를 뭐 이제 심사를 해서 99만 원을 줄지 말지 이제 심사를 하는데 만약에 이 노인 환자를 뭐 수술을 하고 뭐 아까 봤던 뭐 하트 페일러 이런 걸 수술을 하고 너무 빨리 퇴원시켜 가지고 환자가 다시 30일 이내에 왔으면은 99만 원을 돌려줄 거를 뭐 예를 들어서 90만 원만 준다. 아니 뭐 10만 원만 준다. 이런 거거든요. HRRP라는 게. CMS 입장에서. 그래서 이 노인 환자나 저소득 환자가 아니면 이 강제성이 없어요. 근데 어쨌든 기본적으로 그냥 이 정신 자체는 이제 리어드미션 프리딕션 자체는 이제 당연히 뭐 제너럴하게 적용이 되겠죠. 병원 입장에서 너무 함부로 빨리 뭐 이렇게 퇴원시키고 그러면 안 되니까. 그래서 그 노인 환자나 저소득 환자는 CMS가 담당을 한다. 그러면 이제 뭐 젊은이들은 보통 뭐 이제 미국에 있는 뭐 카이저 퍼머넨트니 뭐 가이싱건 이런 이제 뭐 많아요. 인슈런스 회사들이 굉장히 많은데 그런 회사들도 비슷한 프로그램을 돌릴 수 있죠. 그런 회사들도 이제 뭐 병원한테 리임버스 하기 전에 너네가 너무 빨리 퇴원시키면 우리 리임버스 많이 안 해줄 거야. 뭐 이런 거 할 수 있겠죠. CMS랑 똑같이. 그래서 리어드미션 프리딕션 자체는 그냥 제너럴하게 중요하다. 이렇게 보시면 됩니다. DB를 만들기 어려운 환경인 것 같은데 혹시 가상 EHR 데이터를 만들고 활용한 방법의 연구들도 있나요? 네, 아주 좋은 질문인데 제가 이제 주 후반기에 다룰 여러 가지 그 토픽 중에 신테릭 데이터가 있습니다. 그러니까 이제 EHR 데이터를 합성해가지고 그거를 DB로 DB화 시키고 그걸 이제 오픈 소스 시켜가지고 하는 것 자체도 이제 당연히 중요한 방법 중 하나인데 중요한 주제고. 근데 EHR 합성하는 것 자체도 이제 아직까지 그렇게 막 잘 되고 있지는 않고요. 그 이미지 쪽이 잘 됩니다. 이미지는 뭐 원래 겐이나 뭐 스타일 겐 이런 게 고해상도 이미지도 잘 되기 때문에 그래서 이미지 쪽은 잘 되는 분야가 있다. 네. 뭐 엑스레이나 MRI나 뭐 메모그래피 이제 뭐 가슴 뭐 이런 쪽 또는 뭐 안구 쪽 이런 거에 이제 잘 만들어질 수 있는데 EHR 자체 그러니까 이제 누가 언제 왔고 누가 무슨 처방을 받았고 누가 무슨 진단을 받고 수술을 받았다 이런 거는 만들기가 그렇게 쉽지 않은 게 이게 사실 시간 개념이 녹아 있거든요. 그러니까 이제 순서가 있기 때문에 그러니까 이미지는 그냥 찍으면 되잖아요. 그냥 이제 겐으로 찍으면 되는데 이 EHR은 사람의 인생이 녹아 있기 때문에 이 순서와 어떤 그런 것들, 시간 개념과 어떤 인과관계 이런 거를 이해하고서 만들기가 그렇게 쉽지가 않습니다. 그래서 EHR 데이터를 잘 만드는 것 자체도 사실은 정부 과제에 있어요. 합성 데이터를 어떻게 잘 만들 거냐, 그것도 정부 과제 중 하나입니다. 그래서 잘 되면은 말씀대로 이제 오픈 소스를 해야 되는데 그것도 또 문제가 있어요. 너무 비슷하면은 이제 합성을 했는데 너무 비슷하면은 또 그거 자체가 또 이제 그 개인정보 유출이 될 수 있거든요. 합성시키라고 했는데 그냥 복사를 해버렸다. 내가 이제 그냥 내가 알고 있는, 그러니까 걘 입장에서 뭐 합성 모델 입장에서 내가 학습했던 애들 그대로 그냥 복붙을 하고 있다. 이런 문제가 되겠죠. 그럼 이제 그대로 개인정보 유출되니까. 그래서 어떻게 하면 개인정보를 유출을 안 시킨 상태에서 가장 그럴듯한 합성 데이터를 만들 거냐. 또 굉장히 어려운 개념이죠. 네. 그것도 아주 중요한 연구 주제 중 하나입니다. Alright, so we're gonna right, we're gonna move on to the next one. So this is, yeah, so this is related to who asked the question? So yeah, 현지황, so 황현지님이 물어봐 주신 거랑 같은 내용인데, 네. 아이고, 잠시만요. 죄송합니다. I'm sorry about that. All right, so related to what Hyunji Hwang asked, so what does the hospital want to do with the readmission prediction model, or what should they do? So ideally, so what we should train, how we should train the model is like this. So so before, what I said is this, at this time point, we are to predict whether this readmission would happen or not. But ideally, what we should do is actually not use all this information, but only use this information, because we need to preserve some time to take action. I mean, not us, but for the hospital. So in the hospital's perspective, before they release or discharge the patient out of the hospital, they need to make a prediction. And if the prediction says this patient is likely to end up back in the hospital, then they need to do something else. They need to like do more treatments or whatever. Like they need to keep keep her or him around for maybe extra few more days. So anyway, so we need some time or the hospital needs some time for taking action. So how much time? So how much time should we preserve when constructing the data, constructing the training set? So we don't want to use all this information. Oh, by the way, so dependency from all previous records. So this is, again, I think, who asked the question? Yeah, so 변형진님이 물어봐 주신, 이제 지난 방문을 포함한 두 기간 모두 기반에서 하면 안 돼요. So yeah, we could use all previous records, but how previous? How much are we, like, should we go back all the way like 5 years back or 10 years back, or is 1 year back enough, or maybe 1 month back enough? Like, that's an important question. So how much previous should we go back, like, and how much time should we preserve? So should we use all this information, which is not a good idea? Should we use maybe this much information, or this much information, or this much information? So that is all up to the not to us, unfortunately, but to the doctors. So when we are to train a prediction model for hospital deployment, ultimately, if we want to deploy some model, if we want to train some model and then deploy to the hospital to make money or whatever, to run business or whatever, then you need an expert opinion, at least some domain knowledge, before you train your model. When starting from how to construct the data set, you need expert opinion since the beginning. So because I can't answer this question, so it's the user or the client who can define this question. So it's the destiny of the engineer. So because we are not the user, the users would be the hospital or the doctor. So we need to listen to their request. Right. So second one is ICU readmission, but actually we are already almost out of time. So we can start from, this is not too different from before. So this just a preview. So this is it's the same ICU readmission prediction. It's the same readmission prediction, but unlike the hospital readmission, this is given the current ICU admission, predict whether the patient will return to the ICU within the same day, within the same hospital stay. So before it was given the current hospital visit, so it was the hospital level thing. So I'm not sure if you guys remember, but before there was, when I was describing the mimic3 data set, there was hospital level table, and then there was ICU level table, like the admissions or diagnosis procedures. They were hospital level tables, and then the lab events or note events or ICU stays, they were ICU level tables. So again, so the hospital, this task 1 is hospital level thing. Task 2 is ICU level thing. So given the current ICU admission, given the current ICU stay, predict whether the patient will return to the ICU within the same hospital stay. So that would be another readmission prediction that we could do. So I think we may have like a couple more, maybe 5 more minutes. So just why we do this is why predict ICU readmission. So hospital readmission, we already established all the background stories, like what CMS doing HRRP program, and why it's important for the hospital to, financially important for hospital to predict readmission accurately. But why predict ICU readmission? So there's no law or government program for this. Like there's no legal or financial motive for doing readmission prediction. I mean, doing ICU readmission prediction. So ICU readmission prediction. Just a simple example, like here. I'm sorry. So here, if this patient, so this is a single this blue thing is a single hospital stay, and then the red thing is a single ICU stay. And in this case, this patient, within the same one hospital stay, within one blue bar, this patient was admitted to the ICU twice. So this at this time frame, this patient did end back up in the ICU within the same hospital stay. So in this case, this is a yes. So this is the gist of the this prediction task. So why do this? If there's no law against it, or if there's a financial motivation for this, why do this? The answer is actually, it has nothing to do with healthcare. Well, not nothing, but it's mostly for our sake. So the reason for doing this is because this is a prediction task we can do based on ICU level records, and that's it. So this is a prediction task we can do based on ICU level records. Before, task 1 was hospital level thing. So we need a hospital level record in order to do task 1. But in task 2, all we need is ICU level record in order to do task 2. So this is better for us, because in EICU dataset, if you guys were there in the previous session, in EICU, there's no way to track a single patient's multiple hospital visits. I've said this. So in EICU dataset, all we have is a single hospital stay record, and that's it. There's no way to track whether a single patient made multiple hospital visits in their lifetime. In Mimic 3, we can do this. In Mimic 3, we can do that. But in EICU, we can't do this. So in EICU, we can reconstruct this record. We can even reconstruct this record, but this we can't. But we need to be able to reconstruct this record in order to do hospital readmission prediction. So which means that using EICU, we can't do this. I mean, we can't do hospital readmission prediction, but using EICU, we can do ICU readmission prediction. So which means that both using Mimic 3 and EICU, we can both do, using both datasets, we can do ICU readmission prediction, which means that we can do transfer learning. So we can train a readmission prediction model, ICU readmission prediction model, using Mimic 3, and then we can transfer that to EICU datasets, or vice versa. But hospital readmission prediction, we can't do that. That is the reason why we might be interested in ICU readmission prediction. So this is most likely for machine learning research purposes rather than healthcare, for like healthcare purposes. I mean, still, it might be beneficial if we can accurately predict whether a patient will be readmitted to ICU again within the same hospital stay, so that the doctors don't prematurely discharge patients from ICU. 그러니까 중환자실에서 너무 빨리 내보내면 다시 중환자실에 막 실려올 수 있기 때문에 이제 그런 거를 방지하는 차원에서는 이제 ICU readmission prediction도 뭐 쓸모가 없는 태스크는 아닌데, 주로 이제 제가 관심 있는 이유는 이건 이제 요 EICU 데이터셋으로도 할 수 있기 때문이다. 네, 요 얘기를 하고 싶습니다. All right, so I think we're almost out of time. So before we end the class, any questions so far? We've talked a lot about healthcare settings and the characteristics of healthcare prediction, like predictive healthcare models, which is a bit different from computer vision or NLP. In computer vision or NLP, we don't need to there's no need to carefully think about constructing the data set, because one, people already done that, and two, it's not that critical, because in healthcare, your prediction model or your study might have an actual impact to human lives. So we need to be really super careful. But in computer vision, like whether you classify a dog or cat, it's not really critical. Okay, so question. 예를 들어 건강한 사람이 급속도로 건강이 악화되거나 이런 경우 이제 이런 걸 얼마 넣느냐에 따라서 예측 결과가 달라질 것 같은데, 예측을 위해 사용할 데이터 기간에 필요한 기본적인 기준이 있나요? 좋은 질문인데요. 이제 급속도로 악화되는 거, 이제 이게 급성 뭐 신장염, 이제 뭐 AK, 뭐 어큐트 뭐가 붙으면 이제 다 이제 급성이거든요. 이제 그런 걸 예측하기 위해서 이전 기록을 얼마나 넣느냐? 사실 많이 넣을수록 좋아요. 이제 많이 넣을수록 좋은데, 이 모델이 처리를 할 수 있는 만큼 넣는 게 중요합니다. 그리고 이제 그만큼 그 모을 수 있어야 되고, 예를 들어서 이제 나는 뭔가 급성 뭔가를 예측하기 위해서 10년치를 모으고 싶다. 모든 사람에 대해서 10년치를 모으고 싶다 이러면 사실 그 불가능해요. 모든 병원이 이제 뭐 다 대형 병원도 아니고 모든 사람이 꾸준히 병원 10년씩 오는 게 아니기 때문에, 이제 난 모든 사람에 대해서 10년치를 모을 거다. 이거는 불가능하겠죠. 그래서 난 모든 사람에 대해서 1년치를 모을 거다. 그건 가능해요. 근데 그럼 이제 1년치만으로 충분할 거냐? 어떤 급성 뭔가를 예측하기 위해서. 이제 그거는 당연히 또 이제 어떤 의사 선생님과 도메인 전문가와 이제 이 상의를 해봐야 됩니다. 그래서 기본적으로는 많이 넣을수록 손해 볼 건 없다. 특히 요즘 같이 이제 모델이 대형화되는 시점에서는 이제 많이 넣을수록 손해 볼 건 없는데, 이제 모든 사람, 근데 이제 너무 그 사람마다 이 방문 패턴이 들쭉날쭉하면은 이제 이 어떤 그 클리니컬 스터디 차원에서는 사실 이제 그게 그렇게 막 좋은 것만은 아니에요. 그러니까 웬만하면은 다들 비슷한 기록을 갖고 있고 비슷한 시점에 뭐 비슷한 특성의 그런 걸 갖고 있어야지 정확하게 이제 어떤 바이어스가 없는 모델 학습을 할 수가 있습니다. 네, 그리고 이제 양동훈님, 혹시 지난 시간 어사이먼트 관련 수의원의 승인까지 완료하신? 네. 요건 조금 걸려요. 한 2-3일 정도 걸릴 겁니다. 그러니까 금요일 밤에 신청했으면은 이게 주말이 꼈기 때문에 이제 그분들이, MIT 분들이 뭐 주말에 반드시 일한다는 보장은 없어서 아마 비즈니스 데이로 한 2-3일은, 최소한 2-3일은 걸린다고 보시면 됩니다. 네, 알겠습니다. 네, 뭐 다 네, 제가 이미 다 이제 학생분들 뭐 리스트를 그쪽에 넘겨서 그쪽이 저한테 딱히 아마 연락 안 하고 바로바로 신청 넣으시면 바로바로 해줄 거예요. 그래서 뭐 누구나 다 받으실 수 있을 거고, 그러니까 이제 청강하는 분들 또는 오늘 네이버 분들 안 오신 것 같은데 나중이라도 하여튼 이제 KLMS에 등록이 안 되신 분들은, 이제 나는 미믹3 가지고 프로젝트까지 하고 싶다 이러신 분들은 저한테 따로 연락을 하셔야 됩니다. 그럼 제가 이제 그쪽에다가 또 얘기를 해드릴게요. 이 MIT 쪽에다가. 네. 네, 그럼 뭐 더 이상 질문 없으시면, so if there are no more questions, we'll wrap up the class today, and I'll see you guys next Thursday. So thank you and bye bye.